So our zeros are going to be what? 2 and negative 1. What's the 2 doing? Touching. And the negative 1 is crossing. Our end behavior was a positive odd. It was a positive odd, right? So that means that it's doing this, right? He's coming out like this. So there's our end behavior. So we know that the graph has to somewhat mimic that ending, right? And we know that we have, it was a degree of 3, so we know we have 2 turning points, right? So we know we have 2 turning points. And what is our y-intercept? But how do we find y-intercepts? We plug in zeros for x's. If we plug in zeros, we're going to have 0 minus 2 squared times 0 plus 1. What's that going to give you? 4. Well, I'm going to give you a 4, so your y-intercept is 4. All right, so let's graph it. So I have a negative 1 over here, and a 2 over here, and a y-intercept of 4. Okay. We know that our end behavior must mimic the end behavior of our positive odd, right? So we know that at that negative 1 it is crossing. So we know it's crossing. So you can kind of get a hint at what's going to be happening down here. What's happening down here? You already know what's happening because you know the end behavior, right? So it's going down like this. And it's going to come up, and where's it going to hit? It's going to hit right there at that 4. We don't necessarily know if that's truly where it hits, where it maxes out, but we do know it does have to cross. And then it's going to have to do what? It's got to head back, right? It's got to head back to that x-axis because it's got to hit our second 0 of 2. So we'll bring it back, and then it hits that 2, but this time he does what? He touches, and then he bounces back up. Okay? Does that mimic our end behavior? Does that mimic our end behavior? Does it have 2 turning points? Okay? So this may not be exactly what it is. We may not max out at that 4, but for sketch-wise and for doing inequalities, this is a good enough sketch for us. Okay. Any questions on that? So what we have is we want to know when this, let's go back to our original inequality. We wanted to know when this is less than 0. We want to know the x values that will make this polynomial less than 0. And we're referring to our y values, right? So if I'm looking at my coordinate plane, where are my y values less than 0? So here's my x-axis. Where are the y values less than 0? In accordance to your x-axis. Above it or below it? Below it. This is where x is less than 0, right? Because these are the what? The negatives, and the y values that are greater than 0 are where? Above it, positive, okay? So we kind of look at this and we kind of break it into that type of scenario. My negatives occur down here. These are my less than zeros. These are my less than zeros or less than or equals. And then if I'm above, those are my greater than or my greater than or equal to zeros, okay? Because that's where my y is positive. So if we're looking at this, we wanted the values of x that would make this thing what? Less than? Where is our graph below? Where is our graph below? At x equals negative 1, and where? What are the rest of the x values? What's happening? What's your end behavior? As x is going to what? Negative infinity, y is going to negative infinity. So we see, in fact, that to satisfy this inequality, we only want the values of x that are from -1 to negative infinity. So that we're only interested from here on over, right? Because that's where we are below the x-axis. Are we going to actually include the -1? Is -1 part of the solution set? No. Why? Because we don't have the equal, right? It's just less than. It's not less than or equal. So if we write this in interval notation, remember interval notation, we always go left to right. We always start with the smallest amount and go to the highest amount. So as I'm going from left to right, what am I going to hit first? The infinity or the -1? The infinity. So the infinity is listed first. So we would do negative infinity. Is that a parenthesis or a bracket? Parenthesis. Right? Always. Right? And we are not including the -1, so is the -1 a parenthesis or bracket? Parenthesis. Okay? So after all of that work, your answer is the interval. There's your answer. What would that look like if we just wrote it as an inequality? X would be what? Less than
or equal to -1.
Well, not equal to. Because we started with, so just less than. So if I say x less than 1, am I including all these numbers that go to negative infinity? Am I including all these numbers? Yeah, I am.
Oh, yeah.
Yeah. If I said x was a -10,000, would that satisfy this? Yes. If I said x was a -10, would it satisfy this?
Yeah.
Yes. So either of these are an acceptable answer. Okay? Yeah. The first thing we're going to have to do is move that 3x. So let's do that. So that would give us x cubed, plus 2x squared. It moves over, so it becomes negative. And that would be greater than or equal to the 0. Let me rewrite that. To the 0. Okay. So our next step is to do what? Our next step is we need to find our zeros. We still are focusing on that x-axis. We still need to find what is happening on that x-axis, and the only way we can do that is to find our zeros. So what are we going to factor in this one? Oh, I missed this 2x squared, didn't I? We're going to take out, we can only take out the smallest power, which is the x to the first. Okay, so let's do that. So it leaves us with x squared plus 2x minus 3. Then let's factor that. Will your x method work on this one? It could. Let's try it. Factors of -3 that when added together give you a 2. What would those be?
-3 and 1. No, never mind. I did that wrong. My bad. 3.
So just flip it, yeah. So it would be +3 and -1. Yes, very good. What was the degree of this problem? 3. This had degree 3, so that means we're going to have
Zeros.
3 zeros. Do we have 3 zeros up there?
Yeah.
What are they?
X, -3, +1.
No, the x, but the
Oh,
0. Yes. So the x gives us a 0. The 3 gives us our -3, and the -1 gives us our 1. Okay. Now we're going to take those and we're going to put them on our number line or our x-axis. So let's go to our x-axis. So we're going to have -3. Then we would have 0, and then we would have 1. Our inequality symbol is greater than or equal. So you've already got your zeros on here. Would they be open or closed? Would they be included or not? They would be included if they're a part of the solution set. So we'll put them already as included by putting closed points. So put your closed points. So always do that first, and you don't have to mess with that again. You can just establish that from the get-go. So now what we want to do is we're going to go back and we're going to use a test point in all of these intervals. So we're going to test a point from -3 to -infinity. We'll test a point between the 0 and the -3. We'll test a point between the 0 and the 1. And then we'll test a point from 1 to positive infinity. Okay? So we had 3 zeros, and we'll have to make 4 tests. You always test one more than whatever your zeros are. So let's take this area right here. What's a number between -3 and negative infinity? -9? So let's test it. Okay, so -9. So that would give us a -9 times a -9 plus 3 times a -9 minus 1. Okay, you do not have to come up with the numbers. All you have to come up with is the sign. So -9 will automatically be negative. What's -9 plus 3? Positive or negative? -6 would be negative. And -9 minus 1 would be -10. So that would be negative. So if I multiply a negative times a negative times a negative, what's that going to give me? It's going to give me a negative. So you're... Okay. So you're going to come over here from -3 to negative infinity. That is a negative. So you're going to put the negative down here at your number line. Now let's test a value between -3 and 0. What do you want to do? Between -2? So we'd have -2, -2 plus 3, -2 minus 1. So -2 again would be negative. What about -2 plus 3? Positive or negative?
Positive.
It'd be a positive 1, wouldn't it?
Yeah.
Okay. And then -2, -1? Negative. All right. What's a negative times a positive times a negative? Positive. That's positive. So put a plus there. Positive. Okay, now we're between 0 and 1. What do you want to test there? A half? Okay, so we have a half plus 3, and a half minus 1. All right, a half is positive. A half plus 3? Positive. Oh, I didn't change my color. Hold on, let me. Okay, so the half was positive. The half plus 3 was positive. Or is that supposed to be it? Yeah. And then a half minus 1 is, what's a half minus 1? Positive or negative? Would that be a negative? So what's a positive times the negative? Positive times negative. Negative. Double check. So put that between your 0 and 1. We got a negative, and we have one more. What do you want to test? It's a number above 1.
9,000.
You and your 9s. Okay. All right, so 9, a 9 plus 3, and a 9 minus 1. Is that your lucky number? 9?
Yeah.
Is that your soccer number? You play soccer?
No, what's our number 23?
Oh.
I was born
Somebody
on
having...
the 9.
Oh, okay. All right. Okay, so 9 is positive. What's 9 plus 3? Positive. And 9 minus 1? Positive. So a positive times a positive times a positive is positive. All right. So we wanted, our inequality symbol is greater than or equal. So we are looking for when your polynomial is above or below the x-axis. Greater than? Above, the positives. Which are the positives, right? So our solutions are right here and right here. So we go from -3 to 0. And then we go from 1 to positive infinity. So we said that we were including these this time, so do we use parentheses or brackets? Brackets. So we'd have a bracket, -3, and we go to 0. He's also included. Now we have a gap. We have this gap, and what's happening here? Obviously, we have something going right below. We went down, and he's below, and he's popping back up here. So we have to split them up when we write them down, so we'll use a U for union or and. It's kind of and then we would use 1. It is also included. To positive infinity. Is infinity a bracket or a parenthesis? Parenthesis. Okay. And this right here, your intervals are your answer. That's your solution sets.